So this is the last part of the theorem 18.1, that is 4 implies 1. Okay, this is the last part. So you are assuming the fourth condition and you will prove the first condition, that is f is continuous. So the fourth condition is there exists a neighborhood. Actually it looks different here in the statement. For each x, can you see that? I will show you. Fourth one, for each x belongs to capital X and each, you are assuming this, okay, but you are writing in a different manner there. Okay, so to show the difference, I am now reading this. For each x belongs to x and each neighborhood v of f of x, there is a neighborhood u of x such that f of u contained in v. Actually, this is very easy. You have a function f from x to y, right? You have to say, now you are going to say 4 implies 1, that is 4 is this, 1 is f is continuous. Okay, that is you have to say this function is continuous. So you have to know something that already I explained you. Again I am explaining. In this topological space x, you have a point small x. Okay, and you are taking a neighborhood of this. Using this point x, small x, you are drawing a neighborhood and that is capital U. Okay, the name of the neighborhood is capital U. Is that clear? Now, here, so the image of x will be what here? F of x, okay. This function f of this point x. This is what the image of this x. So, f of x belongs to capital Y. So, here, you are drawing a neighborhood for this f of x and that neighborhood is denoted by capital V. If that's so, then f of u contained in V. That is right, because u is here. U is the neighborhood belongs to the from this topological space capital X. So when you talk about f of u, then that will be in this area, right? F of u, that will be contained in capital V. That is obvious. Not obvious. Actually, if there is a point x, then if that point, the image of that point is f of x. Then if you are having a neighborhood u from this topological space x, then f of u will be contained in V here. Okay, so that is what they are trying to convey from this line. Okay, I hope you got some hint from what I have explained you now. Okay, so now we are going to prove f is continuous. So here you don't write the same sentence here, the assumption, you will write in a slightly different manner. The neighborhood ux of the same thing, but in the place, instead of writing neighborhood u, here you write ux, because you are taking this neighborhood ux for the point small x, right? Small x belongs to capital X topological space. I explained you. Okay, so here there is a neighborhood ux of small x such that f of ux contained in V. This is what you are assuming, the same sentence, but only difference is instead of u, you are putting ux. That's the only difference. Okay, to prove f is continuous, you are going to prove f is continuous. To prove f is continuous, we know f from x to y, we have a mapping. So if you want to say this f is continuous, it is enough to prove what? We have a neighborhood V here. Neighborhood, every neighborhood has an open set. We have to say f is continuous, it is enough to prove f inverse of V. This is open set. Its image is open in X. It is enough to prove f inverse of V is open in X. If you prove that, then obviously f is continuous, you can say. So that is what you are going to say at the end of this part. So in between there are some processes that you have to keep in your mind. So that is consider the assumption part. take the assumption part, and taking F inverse on both sides, you will get this. And this can be written as F inverse and F get cancelled, and you will get Ux only here. So Ux contained in F inverse of V. And you are rewriting this line like this. F inverse of V is equal to, okay, Ux contained in here. Ux will be in this F inverse of, okay, F inverse of V. So this can be written as F inverse of this, F inverse of V is equal to union X belongs to F inverse of V, right? X belongs to F inverse of V into Ux. Okay, so here from this you can say this F inverse of V is the union. This is open set, right? You are taking union. So F inverse of V is the union of open sets. Therefore, you can say F inverse of V is open in X. So therefore F is continuous. That is how you are saying. You are concluding this proof. Okay, I hope you understood. Right? Okay, thank you.